a solutions engineer at Snyk, and today I'm going to give you some tips on how to become a secure developer in Go. The 5 topics we're going to discuss are using Go's standard crypto libraries over third-party ones, using the HTML template to avoid cross-site scripting attacks, securing your open source code, sanitize all input data coming in or out of a subshell, and lastly, deploying your code in a secure manner. Let's get started. 4 reasons we may want to encrypt our code would be: we want to avoid data breaches. We don't want anyone to steal our code and use it in a malicious manner. We also want to guarantee its safety in transmission, so we actually want to encrypt the code before we transport it. Next, we want to guarantee the data's integrity and make sure it's accurate. And lastly, we all have some regulatory requirements we have to meet, and a way to hold that is to actually encrypt our data. Luckily, Go has standard crypto packages, and we should use the Go ones rather than the open source ones because the Go crypto libraries are audited by security researchers. And I know they're not all inclusive and you may want to use the open source libraries. However, just like you're not using or writing your own cryptographic algorithms, you shouldn't be using third-party ones, especially since they're not well maintained and audited. So be wary of the third-party crypto packages and know your source. Unfiltered strings passed to the web client using the io.writeString or the text template can expose your users to a cross-site scripting attack. This is because any HTML tag in the string returned will be rendered to the output string without any encoding. They may also be sent with an incorrectly defined content type plain text response header if not explicitly set. Using the HTML template is a simple way to automatically web encode content returned rather than trying to make sure you manually done it in your application logic. The OWASP Go SCP documentation has an excellent chapter and example detailing this topic. In case you're using open source libraries, make sure they're secure. Use tools like Snyk to test your application for known vulnerabilities. With a simple command called Snyk test, you can have full visibilities of all the vulnerabilities in your project. In addition, Snyk will give you remediation advice to help you fix those vulnerabilities. You can also use Snyk to fail builds in your pipeline. Snyk test returns an exit code between 0 to 3. If it's 0, it means no vulnerabilities were found and you're good to go. If it's 1, 2, or 3, it means there's issues, and using that exit code, you can break that build. And if you don't want to break the build, that's fine. You can use Snyk Monitor, and as the name suggests, it helps continuously monitor your project in case new vulnerabilities are found later on. I want to quickly demo how you can use Snyk to help you find and remediate vulnerabilities in your project. In the demo, I'll use a vulnerable app, I'll exploit it, I'll use Snyk to find the issue and remediate it, and then later on test the application once more to make sure everything is okay. The application I'm using is a simple application that, when given a file in UTF-16, it returns hello with the word in the file written in UTF-8. And we see that the CPU usage is pretty much even across all applications. My input is just a text file of the word world. And let's give it as input to our application. As expected, we got hello and then our input, which was the word world. Now let's try to do this with a different file, our dos.txt. We see that the application is running, but nothing is happening. Let's check out the CPU usage. We see that our application is taking a huge percentage from our CPU. So now let's get out of our application and run Snyk Monitor to see what are the issues. Snyk Monitor is going to take us to Snyk's UI. And in the UI, we can see where the issue is introduced and where it is fixed. We can see that we need to upgrade to version 0.3.3. And if we go to the dependencies tab, we actually see our dependency tree and all the dependencies that we have in this project. So let's fix our vulnerability. Great, we upgraded from version 0.3.2 to 0.3.3. Let's run a Snyk test to see that the issue is solved. Awesome, no new vulnerabilities were found. So now that we know our application is vulnerability free, we can test it again. Using the dos.txt, we see that we quickly get an output. So that means our issue is fixed, and we see that our CPU usage is back to normal. In Go, a subshell basically gives direct shell access to your system. Therefore, always prefer to use solutions written natively in Go code using the appropriate modules. If you do find yourself needing to use a subshell, make sure that you sanitize all outsourced data that may be passed in. If you don't sanitize the data, it can allow someone to inject something malicious. In addition, this can lead to unwanted changes in the file system or call external dependencies. Therefore, always make sure you're sanitizing your data. In case you missed a cross-site scripting issue or an SQL injection, rest assured because Snyk Code is planning on introducing support for Go in Q4 this year. This will help you find first-party security issues in your code. It will also show you the data flow from the source all the way to the sink, step by step. It's going to give you details about the issue, what this issue is, how you can prevent it, and in addition, it's going to give you fix examples. Let's see what it looks like. On the left, we see the data flow from the source, and then a couple steps all the way to the sink. And on the right, we see the actual code. In the Fix Analysis tab, we have details explaining the issues, the type of attacks, for example, and how you can prevent them. And we also have some fix examples that we found in open source. In terms of the modern development, customers are creating containers and deploying them to the production environment. Now, we tested our application in the pipeline, but let's talk about infrastructure as code. You may be using Kubernetes deployment files, or maybe CDK on AWS, which I know is really hitting off, and you can actually write it in Go, and it will be transformed into a CloudFormation template. So Snyk can scan that Kubernetes file, CloudFormation, and Terraform files, and list misconfigurations that can become major security vulnerabilities. And the best part is that it finds it before the deployment. In addition, it also gives remediation advice and how the issue can be solved. So those are the few tips I have for you on how to become a secure developer in Go. Some next steps I have over here: the Go crypto libraries, Snyk Go cheat sheet on best practices, and Snyk's Go documentations. You can go to Snyk, you can sign up for free and start testing your application for vulnerabilities. Develop fast and stay secured. Thank you for listening.